Now we'll start with the memory system. So இது வரைக்கும் first நம்ம basic concepts பார்ப்போம் என்ன சொல்றாங்கன்னு, then we'll go with all other things. So for example, that is the maximum size of the memory that can be used in computers determined by the addressing schemes. So for example, if you're going to have a 16-bit computer, if you're going to have 16-bit computer that generates 16-bit addresses. இப்போ நம்மக்கிட்ட 16-bit computer இருக்கு, அதே மாதிரி 16-bit address இருக்கு. If you are going to have 16-bit computer generate 16-bit addresses which is capable of addressing up to how many bits? That is 2 power 16. So you will be having 64k memory locations. So here, if I'm going to have 32-bit address, what happens? I will be having 2 power 32. So if you're going to have 2 power 16 locations, so what happened in this? Totally we will be having 64k memory locations. You will be having 64k memory locations. So this is the thing which happens. So if I'm going to have 2 power 16 address bits, it will be having 2 power 16 is equal to 64k memory bits. On the other case, if I'm going to have 32-bit address, 32-bit address என்ன ஆகும்? You will be having 2 power 32. So for this, you will be having totally 4 giga memory locations. You will be having 4 giga memory location. GIGA. ஏன் வர மாட்டேதுன்னு தெரியல. GIGA. So this is how you'll be having. So totally 4 giga memory bytes it occupies in the location. So here, if you're going to see to the diagram, so as you know, we are having the processor and the memory, which shows the possible address assignments for a byte addressable 32-bit computer. The big Indian arrangement here, it is used 68,000 processor. So what happens in this case? You take an example, a byte addressable computer whose instruction where it is going to generate 32-bit addresses. When a 32-bit address is sent to the processor to the memory unit, the higher order 30 bits determine which word will be accessed. If a byte quantity is specified, the low order 2 bits of the address specified. So which byte the location is involved? In a read operation, other bytes may be fetched from the memory, but they are ignored by the processor. If the byte operation is a write, however, the control circuitry of the memory must ensure that the contents of other types of the same word are not changed. So here, if you are going to see in this part, the data which is going to transfer between the memory and the processor. ஸோ இங்கே இருக்கிற எல்லாமே டேட்டாவுமே எங்கேருந்து பாஸ் ஆகுது? ஃப்ரம் தி மெமரி டு தி ப்ராசஸர் அண்ட் அகெயின் ப்ராசஸர் டு தி memory. This is how the data transfers. So we are having two things, that is MAR and MDR, that is in the processor, where it will also hold the arithmetic logic unit, that is which we call it as ALU. ஸோ இங்கே ஏஎல்யூ இருக்கும், மெமரி அட்ரஸ் ரெஜிஸ்டர், மெமரி டேட்டா ரெஜிஸ்டர். அப்பார்ட் ஃப்ரம் திஸ் இதில் இன்னும் என்ன இருக்கும் நம்ம பார்த்ததுலேயே, யூ ஹேவ் மெமரி அட்ரஸ் ரெஜிஸ்டர், டேட்டா ரெஜிஸ்டர். Then next you will be having ALU and cache memory. So these are all the contents which is available in the processor. Now MAR, where it is going to have the address bus, ஏன்னா memory address register it itself going to be a bus. ஸோ அப்போ பஸ்ஸு அப்படின்னாலே அந்த path which it is going to take only k bit address bus. Whereas when you're coming for the memory data register, what happens? We have to save the data into the database, and also from the database they have to save it over here. So this is how it's going to happen. ஸோ அதனால தான் இங்கே வந்து பார்த்தீங்கன்னா மெமரி அட்ரஸ் ரிஜிஸ்டருக்கு அட்ரஸ் லைனும், டேட்டா ரிஜிஸ்டருக்கு வேர் வில் பி ஹேவிங் டேட்டா லைன். ஸோ இது ரெண்டுமே தான் மோஸ்ட் இம்பார்ட்டன்ட் பார்ட் டு அக்சஸ் தி டேட்டா ஃப்ரம் ஒன் இன் டு தி அதர். Then next to this, where you can find the control lines, where here the control lines you will be having read or write mode. So read mode, where it is not permitted to write anything into the file, whereas when you're going to have with word, so here you have to write the content into the memory. On the other case, it has to pull it from the memory to the sufferer. So this is how you'll be having the control lines. Then next, when you're going to see about MFC is nothing but memory function complete. So we have two things we have to know: memory function complete and also wait memory function complete. These both things are going to be very common. அடுத்தது வந்து பார்த்தீங்கன்னா, இங்கே நமக்கு தெரிய வேண்டியது அட்ரஸபிள் லொகேஷன்ஸ். அப் டு 2 பவர் k addressable location நமக்கு தெரியும். So word length is equal to, you will be having n bits. So the 2 power k addressable locations, where if you are going to have 2 power 16, that is you will be having 64k. Whereas on the other case, if you are going to have 2 power 32, where we say it is going to occupy 4 gigabits. So this is how the data has been changed. So here the maximum size of the main memory has been addressed according to the address location where it has been given. So here everything, the memory is going to be byte addressable. Here everything is going to be byte addressable. Then next, if you are going to see CPU and CPU, that is a central processing unit, where you will be having the main memory connected to the processor. So this is how the data transfer happens over here. And if you are going to see to this, that is read and write. So in this case, what happens is, you will be having the write operation is involved by setting r and w dash is equal, this line is equal to 0. If you are going to have it is equal to 0, this is how it is going to have with the write operation. Here we also know that where MFC is going to be memory function complete. So the speed of the memory units is the time that elapses between the initiation of an operation and completion of that operation. So for example, the time between the read and the MFC signals. So this is referred to memory access time. So this we have seen to the before itself. So the speed of a memory, where it can be accessed with memory access time and memory cycle time. So how we call this memory access time and memory cycle time? The speed of the memory unit is the time, and that elapses between the initiation of an operation and also the completion of that operation. That is, if that is the time taken to access the data, okay, to perform an operation. For example, you can say the time between read and the memory function complete signals. This is referred to as memory access time. அடுத்தது memory cycle time. So which we are going to have the memory cycle time. Here the memory cycle time, which is the minimum time delay required between the initiation of two successive memory operations. That is the minimum delay required between initiation of two successive memory operations. For example, the time between two successive read operations, the cycle time is usually slightly longer than the access time. We will be always having cycle time is going to be longer than the access time, depending on the implementation details of the memory unit. So here we also talk about RAM. So RAM is nothing but random access memory. So the memory unit is called random access memory if any location can be accessed for a read or write operation in some fixed amount of time that is independent of the location address. So this is how we call it as a random access memory. So here, the another important design issue, where we have to provide a computer system with as large and fast a memory as possible within a given cost target. Take for example, now if you want to buy a computer, now if you want to buy a computer, so what are the various measures or what are the various specifications you will be thinking over for buying a computer? என்ன பார்ப்போம்? ஸ்பீடு. நம்ம இது வந்து எவ்வளோ ஸ்பீடா இருக்கும். நெக்ஸ்ட் என்ன பார்ப்போம்? காஸ்ட் எவ்வளோ ஆகுது. ஸோ these are the things like cost, speed, RAM இதெல்லாமே பார்ப்போம். Whereas the need for seeing this is to have the performance at lowest cost. To see the performance with lowest cost with huge memory. ஒருத்தன் கம்ப்யூட்டர் வாங்கினா அதான் யோசிப்பாங்க. சார் ரேம் வந்து கம்ப்யூட்டர் ஸ்பீடாக இருக்குமா, எவ்வளோ டேட்டா ஸ்டோர் பண்ணலாம், ஹார்ட் டிஸ்குடைய ஜிபி என்ன, ரேம் ஸ்பீட் என்ன, ஓகேவா? தீஸ் ஆர் ஆல் தி திங்ஸ் விச் யூ வில் பி சேயிங். ஸோ இது எல்லாத்தையும் வி ஹாவ் டு கம்ப்ளீட் வித் தி கிவன் காஸ்ட் ஆகுது. ஸோ அது வந்து ஒரு மார்க்கெட்டில் கம்பீட்டபிளாக ஒரு மினிமல் ரேட்டாக இருக்கணும். ஸோ ஹியர் we have several techniques to increase the effective size and the speed of the memory. So one is going to be the cache memory, that is to increase the effective speed, and virtual memory to increase the effective size. Now in the cache memory part we have discussed to the earlier part itself, that is whenever the arithmetic logic unit where it is going to require any operand or data for performing the arithmetic operation, அது போய் மெமரியிலேருந்து எடுத்துகிட்டு வரணும். அப்போ ஒரு தடவையும் மெமரியில் போயிட்டு மெமரி அட்ரஸ் ரிஜிஸ்டர் மூலயமா ஐடென்டிஃபை பண்ணி again with the help of memory data register, if it is able to get it to the memory access time is high. To avoid that, we are going to have the IC chip in the processor itself. ஸோ அங்கே நான் வந்து கேட்ச் மெமரி வைக்கிறதுனால the time taken to access the data is going to be minimal in nature. So the speed can be increased. So you will be having, it will increase the effective speed. So this is the cache memory. Whereas when you're coming for the virtual memory, where it is going to increase the effective size. Difference புரியுதுங்களா? If you are going to have virtual memory, it is going to increase the size. Whereas when you are going to have the cache memory, it is going to increase the effective speed. Then we will go for semiconductor RAM. So before going to this, you should also have the idea about what is virtual memory. Here, the virtual memory is the main thing where each person has to know if you are going to study with the memory. So here the address generated by the processor directly specifies the physical location in the memory. That is the virtual memory na enna solla varum, the address generated by the processor, that is the address generated by the processor directly specify the physical location in the memory, directly specifies the physical location in the memory. So this may also have the various reasons. For example, if you want to become if you want to store in the physical memory locations that have addresses different from those specified by the program, the memory control circuitry translates the address specified by the program to the address where it has been generated by the processor. We call this as a virtual address or logical address. So the virtual address space na enna solrom, the virtual address space where it has been mapped onto the physical memory. இப்போ physical memory அப்படின்றது where you will be having a specified address for the physical memory, where the data or operand will be stored in the physical memory. Whereas when you are going to have the virtual memory, the virtual address space is mapped into the physical memory where the data are actually stored. For example, if I'm going to say D132 D132 அப்படின்ற ஒரு லொகேஷன் டேட்டா இருக்கு அப்படின்னா, வேர் D132 ஏல அதன் நம்ம என்ன அட்ரஸ் இங்கே கொடுக்குறோமோ வெர்ச்சுவல் மெமரி உடைய மேப்பிங் அங்கே மேப் ஆகும். புரியுதுங்களா? D132 A அப்படின்னு கொடுத்தனா அந்த A வந்து டைரக்டா இது போய் வெர்ச்சுவல் மெமரியில் இருக்கிற டேட்டா கூட மேப் ஆகும். ஓகேங்களா? ஸோ திஸ் இஸ் ஹவ் யூ வில் பி ஹேவிங் தி வெர்ச்சுவல் மெமரி. இந்த மெமரி சிஸ்டத்துல நம்ம வெர்ச்சுவல் மெமரி பார்ப்போம். ஸோ அந்த வெர்ச்சுவல் மெமரி பார்க்குறப்ப வேர் வி வில் பி சீயிங் இன் எ டீடைல்டு manner how you will be having the virtual memory. Okay, then okay, then next we have to see about the mapping function is implemented by special memory control circuit often called as MMU, that is memory management unit. Make note of this and also be very clear, MMU is nothing but memory management unit. மனசுல நிறுத்திக்கோ, MMU னா என்னன்றது. That is the mapping function which is implemented by a special memory control circuit, by a special memory control circuit often called as memory management unit. So this mapping function can be changed during the program execution according to the system requirements. That is, if you are going to have, where you are not going to have a static mapping of this memory unit. Instead, at runtime, when you want to change, that mapping can also be changed. Okay, so that's the thing which they are saying with the virtual memory. Then we'll be going for semiconductor RAM memories. Then we'll see about semiconductor RAM memories. So how you'll be having the internal organization of the memory chips. So here, each memory cell can hold one bit of information. Each memory can hold one bit of memory information. Then, memory cells are organized in the form of an array. Memory cells are organized in the form of an array. Then, next to that, if you are going to see with the diagram, you can understand very clearly. So this is the internal organization of the memory, where each memory cell can hold one bit of information. Each memory cell அப்படின்னா நம்ம எதை மீன் பண்றோம்னு பார்த்தீங்கன்னா, இது ஒரு மெமரி செல், இது ஒரு மெமரி செல், இது ஒரு மெமரி செல். இப்போ இங்க வந்து பார்த்தோம்னா where you will be having A to A4 and 0 to 7 addresses. Now here this each memory cell can hold only one bit of information. இது ஒரு memory cell. Each bit of memory cell is going to hold only one bit of information. That is, memory cells are organized in the form of array. இங்க பார்த்தீங்கன்னா இது எல்லாமே where you will be having as a array. That is, here you will be having 0 to 7, whereas word you will be having count 0 to 15. 0 to 15 now totally 16 bits. Here 0 to 7 is 8 bits. So one row is one memory word. All cells of a row are connected to a common line known as word line. எல்லாமே வந்து பாருங்க கனெக்ட் ஆகி where you will be connected to the word line. So word line is connected to the address decoder. So all the things have been connected to the address decoder. Sense or write circuits, which is going to be the bottom, are connected to the data input output lines of the memory chip. Okay, so again I will repeat it. Each memory cell can hold only one bit of information. Memory cells are organized in the form of an array. One arrow, sorry, one row you are having. So one row, uh, one row is one memory word. One row is one memory word. All cells of a row. So here you will be having the cells. This is cell. This is cell. This is cell. So all the cells of the row are connected to a common line. All these have been connected to a common line known as word line. Then word line is connected to the address decoder. இதான் லைன். ஸோ அப்போ வந்து பார்த்தீங்கன்னா ஒன்றும் லைனில் கனெக்ட் ஆகி அந்த லைன் எதில் கனெக்ட் ஆகுது, அட்ரஸ் டீகோடரில் கனெக்ட் ஆகுது. தென் சென்ஸ் ஆர் ரைட் சர்க்கியூட்னு இருக்கு பாருங்க கீழே. சென்ஸ் அண்ட் ரைட் சர்க்கியூட் ஆர் கனெக்டட் டு தி டேட்டா இன்புட் அவுட்புட் லைன்ஸ் ஆஃப் தி மெமரி சிப். ஸோ திஸ் இஸ் கோயிங் டு பி தி மெமரி சிப். ஐஓ கூட அந்த இன்புட் அவுட்புட் கூட கனெக்ட் ஆகுது. தட் இஸ் சென்ஸ் and write circuit. So this is how it happens. Now you can see, that is, this is the point. இதை ஒரு தடவை பாருங்க, பார்த்துட்டு டயக்ராம் பாருங்க, ஒரு கிளாரிட்டி வரும். Next we'll continue with the diagram. So once if you are going to be clear with the memory, where you will be having RAM, ROM, and it goes on. So if you are going to read now properly, it will be helping you to the end, up to the end also. So now you have to decide. Okay. So இப்போ இந்த diagram வச்சு you are very clear. So here what happens totally? The memory circuit where it stores 128 bits and requires 14 external connections for address, data, and control lines. So it also needs 2 lines for power supply and ground connections. So here is slightly larger memory circuit. One is 1K memory cells. Thus, that is 1024 memory cells. So these circuits can be organized as 128 into 8 required. That is 8 requiring a total of 19 external connections. Alternatively, the same number of cells can be organized into 1K into 1 format. So this is how it has been organized for the internal organization of memory storage. அப்போ பார்த்தீங்கன்னா இந்த டயக்ராம் வந்து you should be very clear. பாருங்க, each one is going to be the memory cell. Memory cells are connected to the word line and word line is connected to the address decoder. இங்கே வந்து பார்த்தீங்கன்னா column wiseல you will be having 0 to 7. அப்படின்னா 8 bits. 0 ஆட் ஆகிறதுனால 0வும் ஒரு இதாக வந்துடும். ஸோ டோட்டலி வில் பி ஹேவிங் 8 bits. ஓகேவா? அதுவே வேர்ட் கவுண்ட் பாருங்க, you will be having word 0 to word 15 na the plus 1 you will be having 16 words in the word count. So அதே மாதிரி இதனுடைய இன்புட்டும் அவுட்புட்டும் where it has been connected, that is the memory cell input and output, it has been connected to sense write circuit. So if it is going to be loop, it is going to run over here, otherwise it is going to write the DIO lines. That is நம்ம data path and control considerations பார்த்தோம்ல, அங்கே எப்படி data move ஆகுதுன்னு. In that same way you will be having sense write circuits. So apart from that, each and everything is going to be the memory cells. Okay, then we'll go for SRAM, where this SRAM is nothing but static random access memory. So here in SRAM, where the memories that consist of circuits capable of retaining their state as long as the power is applied is known as static memory. So here the static RAM, which we call SRAM cell, may be implemented. So two inverters are cross connected to form a latch. So here you can find two inverters are cross connected. Two inverters are cross connected to form a latch. The latch is connected to 2-bit lines by the transistors T1 and T1 and T2. So these transistors act as switches that can be opened or closed under control of the word line. இந்த வேர்ட் லைனுக்கு ஆன் ஆஃப் ஓப்பன் க்ளோஸ் அப்படின்றதுக்காக இது ரெண்டும் யூஸ் ஆகுது. ஓகே, வேர்ட் லைனுக்கு when the word line is at ground level, when the word line is going to be the ground level, the transistors are turned off. Touch agala, so it is has been turned off and the latch retains its state. For example, let us assume that the cell that the cell is in state 1 if the logic value at point x is 1 and its point y is 0 and the point y is 0. This state is maintained as long as signal on the word line is at ground level. So இங்க வந்து பாத்தீங்கன்னா ரெண்டு ஆபரேஷன் இருக்கும். One is going to be read operation and another one is going to be the write operation. அப்ப என்ன ஆகுது? read operationனா where in order to read the state of SRAM, SRAM is nothing but static RAM cell. The word line is activated to close switches T1 and T2. If the cell is in state 1, the signal on bit line B is high and the signal on bit line B dash is low. So this is the B dash is low when this is going to be high. The opposite is true if the cell is in state 0. Thus B and B dash are the complements of each other. Sense and write circuits. நம்ம அதுல பார்த்தோம். Sense and write circuits where the input and output of memory has been connected to the sense and write circuits. At the end of the bit lines, monitor the state of B dash, B and B dash and set the output accordingly. இப்போ இந்த SRAM அப்படின்றது என்ன அப்படின்னு பார்த்தோம்னா இந்த பார்ட்டு இதோ இருக்கு பாருங்க. So this we call it a static RAM and it has been connected with B and B dash. So this is going to be the latch word countல word line சொன்னோம்ல நல்லா பாருங்க இது வந்து word line. இந்த word line தான் where it has been connected to the decoder. இங்க ஒரு மெமரியும் it has been connected to the sense and write circuit. இதோ பாருங்க இதுதான் நம்மளுடைய மெமரி. It has been connected B dash connect ஆகி word lineல connect ஆகுது. இது ரெண்டும் where sense write circuitல connect ஆகுது. So this we call it as static RAM, that is SRAM. Are you able to understand this part? இதனுடைய continuation part தான். So இது you should not feel very difficult. இதென்ன புதுசா சொல்றாங்க. So this happens with the SRAM. Then next we'll go for asynchronous DRAM. So here in the asynchronous DRAM, what happens is static RAMs, we know that static RAMs are always going to be the fast, but they come at a high cost because their cells require several transistors. So it is going to be less expensive RAMs and can be implemented if simpler cells are used. So however, such cells do not retain their state indefinitely, hence they are called dynamic RAMs. Okay, so it's going to be static RAM and dynamic RAM. Static RAM என்றது என்ன சொல்றோம், where it is going to consist of the circuits which is capable of retaining their states as long as power is applied. Then next you will be having the volatile memories because their contents are lost when power is interrupted. Power interrupt ஆனாலே உனக்கு data lost ஆயிடும். So then access time for static RAM are in the range of few nanoseconds. However, the cost is going to be usually high. The reason enna? Actually, the cost is going to be usually high since it is capable of retaining their state as long as power is applied. And the காரணத்துக்காக தான். When you are coming for the dynamic RAM, where it do not retain their state indefinitely, whereas the static memory it retains the states. Here it do not retain the state indefinitely. Contents must be periodically refreshed. It has to be refreshed periodically, and contents may be refreshed while accessing them for reading. So this is how it happens in the asynchronous DRAM. Then asynchronous first page. Okay, then asynchronous DRAM la how it has been designed. So in the diagram ரொம்ப கேர்ஃபுல்லா பாருங்க. பாத்தீங்கன்னா where you will have a clarity how you are having the internal organization of 2 into 8 dynamic memory chip. So here we know totally 0 to 20, where here each row can store 512 bytes of 12 bits to select a row and 9 bits to select a group. So total of you will be having 21 bits. அதனால தான் இங்கே 0 to 20 கொடுக்குறோம். இங்கே நம்ம 1ன்னு ஆரம்பிச்சோன்னா 1 to 21 சொல்லுவோம். 0ன்றதுனால 20. So 20 plus 1 21 ஆகிடும். So here இந்த ஃபர்ஸ்ட் இந்த இது இருக்கு பாருங்க, this 12 bits 8 9 to 20 இருக்கிற 12 bits where it is used to select the row. A 0 to 8 என்றது 9 bits where it is used to select the row. Then first you have to apply the row address slash where you will be having the row decoder. அதுக்கு முன்னாடி where in the decoder it's going to implement to the cell array. So this is the cell array part which we know where it has been connected. இப்போ for example இந்த part எடுத்துங்க. இந்த பார்ட் இப்போ நம்ம எடுத்துக்க போறோம். இதுக்கான டயகிராம் நான் உங்களுக்கு காட்டுறேன் பாருங்க. இந்த 3 இது இருக்குல்ல, இந்த 3க்கான டயகிராம் தான் where we have seen at the internal organization of the memory. Address decoder இருக்கு, sense write circuit இருக்கு. Address decoder, sense write circuit, and this is the cell array where we have shown an in-depth design of the diagram, how it will be. Okay. So this happens here. From here again you will be having the column decoder. Here you are going to have the row decoder. From here again you will be having column address latch. So this is how row and column has been selected. So this we call it as asynchronous DRAM.